Okay guys, 3.9, we are at the last section of chapter 3. I know, it's crazy. This was a really long chapter, I promise you it's the longest chapter, alright? So we are at 3.9. There are just two, that's it, just two new derivative rules. That's it, okay? So, derivative of exponential and logs. So, in general, the derivative of exponential and logs. So, let me remind you of what we know. Because we know one special exponential and we know one special log rule, okay? So, we know this one, e to the box. We know that one. So, that is when we take the derivative of e to the box, it's e to the box times box prime. So, we know that one. The other one that we know is ln box. So ln of anything, we take the derivative, and it's 1 over box times box prime. Okay, that's easy enough. So those we can remember. So here are the new ones, okay? So here's the difference, and then we'll look at this again. So this means that any number to the something x power is going to be exactly the same. So this is e's a number, right? So it's e to the power. See how e to the power? So like 2 to the power of x is going to be 2 to the power of x times ln of, let's say, 2. What would it be here? It would be ln of e. What's ln of e? Oh, it's 1. So we didn't have to do it here. Times box prime. So there's this extra step right here where you take the ln of the base. And then when you take the ln of this base, you get 1, which is, you know, really nice, and we didn't have to do that, okay? So what about this one? A log. So this is a log, right? ln's a log. It's log base e. So log base e of box. That's what this is. This is log base anything. So e's are special. E's are very special, okay? But log base anything of box is going to be 1 over box. Ooh, that looks familiar. 1 over box times ln of b times box prime. What is ln of b? That's ln of the base, but what about this? ln of b, if we wrote it on the bottom, would be ln of e, because that's the base here of a natural log. ln of e is, again, 1, so it doesn't change this. So these are more specific, well, actually, this is more specific version of these general rules. Okay, so how do these work? Let's give it a try. So we're gonna, so it says use these rules to show that that is true. You do it. You do it. Come on, do it. Do this and do that and show that it's true. Don't just copy me. Don't be a copier and a liar. Okay? All right. So we know that that is in the end what we're trying to get to. Okay, do it again. Do it with this. Do this equals, and then do this side. What do you get using that rule? So what do you get? And then right, and then do you end up with that? Come on, don't copy me. Don't be a cheater. Okay, so then you get that, right? Okay, and then let's try an example. So if y prime equals, let's start with this one. So this is log base 3. Okay, so that's a log rule. So I should be able to use this log rule, okay? So log, I'll show you the rule again. It's right here. So log base 3 of 5x squared is going to be 1 over 5x squared, so 1 over box, times ln of the base, ln of 3, times box prime, which is 10x. All right. You clean that up a little bit, right? 10 divided by 5 is 2. There's an x on the bottom, and then ln 3. That's all you're doing. Okay, try this one. What might you do first because you are not a sucker? Don't be a sucker. Yes, log base 7 of 7 is 1. What do you do with this power? Well, actually, the power comes forward. So really, did you realize that? Really, this is why. Okay, I haven't done any derivatives yet, but really that's why. So be careful. Simplify first. And then, okay, you know how to find a derivative of that, right? So it's just going to be 2 cosine 2x. Okay, so let's try more. I think you should do them. I really do. I think you should do them and not copy me. So you try each of these. You're in a good spot. Yeah, you try each of these, and then you check. So this is 12 to the power. What do? You write 12 to the power times ln of 12 times the derivative of all of that. And there's nothing you can do with that, so you just leave it alone. Okay, what about that? That actually, we should be able to do that like yesterday. All right, so you do it however you want, and then we're going to check our answer. Okay, I did it like this. So I left it, and then I found the derivative of each piece. And then I just multiplied it up. So your answer and that answer should match. Okay, you didn't have to do it that way, but your answer should match. All right, so these are interesting. This says, find the derivative of y squared with respect to 3x squared. So how do we normally write this? We write, given y equals x plus 1. Okay, so we needed a little bit extra information. But how do we normally write this? We would write, okay, we're going to start with y squared equals, actually, I might not start with that if I didn't know, but I'm going to go ahead and say y squared equals, and then I would square that and get that, okay? So that's going to help me for later, but I might not know to do that, okay? So here's what we're looking for. We're looking for the derivative of y squared with respect to 3x squared. So we're finding like a derivative of this with respect to the derivative of this, and they're both now in terms of x. So I'll say that again. So I want a derivative of this with respect to this, but they're both in terms of x. So I write it out, and then I find the derivative on top, and I find the derivative on bottom in terms of x, right? The derivative, and then the derivative, and then I simplify. That's it. So the derivative in terms of y squared with respect to is really like per, and then the derivative with respect to that. But we just have to remember, really, this is like with respect to x. So it's like with respect to x, and then this is also with respect to x. Okay, so I know it's phrased a little bit weird, but now you should be able to do number 4. So number 4, so thinking about how we did this, it says the derivative of 3y with respect to 2x. Okay, so we know how that's kind of going to be set up, and it does tell you that y equals that. So what are you going to do first? I probably want to make this into 3y. So I start with that. So times 3 gives me that. And then I want to write it this way. The derivative of 3y, which is that, with respect to the derivative of 2x. So something like this, right? So the derivative of 3y with respect to 2x. And then find the derivative on top, find the derivative on the bottom, and then simplify, final answer, done. Okay, so the rest of it, there's no back, yay! You do have homework, and let me just say, for your homework for this year, if it's still 2020, your homework says this, but you're doing every other odd, okay? So I'll fix it for you. You're doing every other odd, all right? So I don't want you to get it mixed up. So you're doing number 1, and then number 5, and then number 9. So you're skipping odd. So basically every 4th, okay? So you're doing that. You can do it on the back of this paper if you want to print out this paper, and you're doing this worksheet. So this worksheet, I'm going to start it with you guys tomorrow, but this is just looking at the graph to get answers, and then number 12 and 13, I would do your work for 12 here, I would do the work for 13 over here, all right? But the rest of it, you can just like write answers basically, and then I'll show you one of these tomorrow. All right, good luck, good luck. I will see you. Yes, we are so close to being done with chapter 3.